Okay, our next topic, beginning in Unit 3, is an extension of derivatives, and we are going to move into implicit differentiation. And this is used when looking for the slope. But you are unable to isolate one variable. Meaning we can't just solve for y. It's not in linear form. So most curves are described by a formula in the form of y is equal to some function in terms of x. And we call this an explicit equation. And what this means is that you can easily get y by itself. However, it's not always practical or possible to get an expression in this form. So when the variables of x and y are all mixed up and you can't solve, meaning you have squares or roots, this is called an implicit equation, and the derivative must be found implicitly. So this is just another way of saying use the chain rule. Now, when we are taking the derivative in this form, you need to start using specific notation. It's super important that you follow through every single time. So here this is saying take the derivative with respect to x of x. So this is just 1, okay? The derivative of x or any variable is just 1. However, when you're told to take the derivative with respect to x, which is what this notation means, of another variable, this is considered y prime, or you're going to start to see it like this, dy dx. Okay, so when you're taking the derivative of x with respect to x, you're still taking the derivative of that, and you could write dx dx, but there's really no point because what is dx over dx? It's equal to 1, so it cancels out. So when you take the derivative of another variable with respect to x, you have to use the appropriate notation, and typically it's the derivative of y with respect to x. So here, when you take the derivative of y, it's 2y using the power rule, but then you have to note that you are taking the derivative of this variable in terms of another. You won't see y primes often. What you'll see is this, which indicates the derivative of y with respect to x. Okay, so I'm going to show you how to use this for this next problem. Okay, and what we're going to do, I've already prepped this just slightly, but we're given a curve here, and this is actually a circle with a center at 0, 0 and a radius of 2. So this is telling us to take the derivative of our function, derivative of y with respect to x, and we cannot isolate this. Typically you would say, yeah, you can solve this and take the square root, but it's super messy, and then trying to take the derivative of that because you have plus or minus is very complicated. That's why we use implicit differentiation. So what we're going to do is take the derivative of this function with respect to x. So when we take the derivative of, here, I'll put it right here, the derivative of x with respect to x, we can just write it as 2x, plus when we take the derivative of y with respect to x, we have to use this notation. So it's 2y dy dx is equal to, and the derivative of our constant here is 0. Since we're solving for dy dx, we're going to treat this as an equation. Okay, so we want to isolate this dy dx. So we will subtract 2x. And divide by 2y. Okay, so this right here is our derivative. It's dy dx. So we can use this to find the slope of anything that we want from this curve. Now what you notice here is we actually need an x and a y, whereas before we only needed an x value. Okay, so this is our derivative. Okay, so in part B it says draw a sketch of the curve. So I already did that. I took care of that. I drew a circle. So now what we want to do, here it says find the derivative with respect to x, meaning find the slope at 0. Well, fortunately for us, we already have the equation for the slope, but what we do have to do is find our y value. So because to find our slope we need our y value, we're going to plug x in here. So this is 0 plus y squared is equal to 4. Now remember, when you take the square root, you get two answers. So what we're saying is y is equal to positive 2 and negative 2 when x is 0. So I have 2 points. They want our slope when we have the point 0, positive 2, and they want the slope at the point 0, negative 2. Okay, so this up here is our equation to find the slope. So we're going to plug in our values. 0 over positive 2 is 0, so this is my slope, and then obviously 0 over negative 2 is also 0. Okay, so what we're going to do is go up here, and we have the point 0, 2. Okay, so it's 0, 2. Okay, we have a slope of 0. That means we have a horizontal line here, right? So I'll draw my horizontal line. And this is letter C down here. And then at 0, negative 2, I have the same thing. And I'm doing this because on the bottom it says draw the slopes. Okay, so let's do it at another point. So again, because this is on the curve, we want it at x equals 1. So first I need to find my y values. So you have 1 squared, which is 1, plus y squared is equal to 4. Subtract 1, you have, I'll just move this over here, y squared is equal to 3. So y is equal to positive square root of 3 and negative square root of 3. So when x is 1, I have 2 separate points. Okay, again, we want to find the slope dy dx at the point 1 square root of 3, and then the slope at 1 negative square root of 3. Okay, so this is an approximate value. I think it's, let's find out what it is real quick. About 1.7. So this value right here is approximately 1.7, negative, approximately negative 1.7. So it gives me an idea when I'm graphing where I need to go. Okay, so when I find my slope, I've got negative 1 over the square root of 3. I don't really need to simplify this at all, but it's negative square root of 3 over 3. This is my slope at this point. And then I have 1 over the square root of 3. And this is the slope. Okay, so we have the point 1 square root of 3, which is like 1 and approximately 1.7. So it's about right here. And if I were to calculate my slope, because this one is negative up here, it's going to go something like this. And again, it's just a sketch to get an idea. So this is D. And then at the point 1, I'm looking at the point 1, negative square root of 3. So we've got 1, negative square root of 3. It's going to be on the circle, because it's, remember, it's on the curve. It's a line that's tangent to the curve. Right here. This is D. And we're just illustrating what's happening. So that's how you find the slopes using implicit differentiation.